Welcome to EDU World Space.
In this problem, we're given that there is a tank which is 8 meters long, 4 meters wide, and 2 meters deep, and that is filled with a fluid with 820 kilograms per meter cube density, and it is filled with that fluid to a depth of 1.5 meters. In part A, we're asked to find the pressure at the bottom of the tank. We know that pressure is density times G times depth. So density for this fluid is 820, G is 9.8, and depth is given, that is 1.5. If you multiply all, we see that then the pressure is 12,054 pascals, and we can write this one as about 12 kilopascals. In part B, we're asked to find the force acting at the bottom of the cylinder. It means that we would need to calculate the area that this pressure is acting on, and that would be this shaded area. So force will be pressure times area, where area in this case is 8 times 4, that is 32 meters squared. So force would then be 12,054 times 32. That would be 3 times 86, 10 to the 5th newtons. And in part C, we're asked to find the force acting on one end of this tank. So imagine that we're looking at this tank from this side, and this is the side of this tank. So we have this one, and so this is 4 meters, since that is 4 meters wide, and the total depth is 2 meters. However, that is filled with a fluid up to 1.5 meters. So we are interested in this thin strip right now. Let's assume that we have this thin strip and the thickness is dx. So this total length is 4. So the area of this would be 4 times dx. All right. Now let's assume that we have an origin located here, and the positive y is in the downwards direction. So as we go down, y is positive. We know that pressure is rho times g times depth. Here depth is the distance measured from the surface, and let's say that that is x. So depth would be x, and pressure then would be 820 times 9.8 times x. Force would then be pressure times area. However, this is a thin strip, and if we sum all those thin strips up, we would find the total force acting on one end. So it means that we need to integrate it starting from 0 to 1.5, since it is filled with water, up to 1.5 meters. We would have 820 times 9.8 times x, that is pressure, multiplied by area, and we found area to be 4 times dx. From this, we see that we have 820 times 9.8 times 4. This is a constant, and from this integral, we would get x squared over 2. Now we need to evaluate this between 0 and 1.5. If we do so, we find the force to be 36,162 newtons.